The human digestive tract is a highly regulated biological security border, selectively allowing nutrients through while blocking microscopic threats. To maintain this border, intestinal cells rely on microscopic structural staples called tight junction proteins. These fasteners lock the cells firmly against one another, creating an unbroken wall. This delicate, dynamic state of stability is our primary defense line against a constant flow of passing toxic waste. Severe physiological stress, illness, or even intensely spicy food can shock this system into a high emergency status. Microscopic alarm sensors on the cells, called toll-like receptors, detect the distress. They immediately flip a genetic danger switch inside the cell, known as nuclear factor kappa B. The local temperature inside the intestines rapidly rises. This sudden, sweltering heat creates a hostile environment that quickly kills off our resident friendly microbes. Under this intense heat and inflammation, the tight junction proteins snap apart. Harmful waste and bacteria seep directly through the open gaps and into the bloodstream below, triggering a sharp spike in a systemic swelling marker called C-reactive protein. The gut is now in a state of critical biological failure. The system cannot heal itself until this overheated, hostile environment is systematically stabilized and cooled down. The arrival of a specific biological reset meal, curd rice, intervenes directly into this chaotic digestive tract. The thick texture of the food behaves like a physical, soothing shield. It coats the raw, damaged intestinal walls and immediately drops the searing local temperature. This thermal drop forces a chemical de-escalation. Cellular panic subsides, and severe swelling markers like interleukin-1 beta and TNF-alpha plummet. With the immediate danger passing, the cells release interleukin-10, a specialized chemical messenger traveling through the tract to tell aggressive immune cells to stand down. This physical cooling phase is the mandatory prerequisite for recovery. If the environment remains hot and inflamed, no active biological helpers can survive long enough to begin the actual repair. Because the local temperature and acid levels are now stabilized, the billions of live probiotics suspended within the curd can safely enter and survive the tract. These friendly microbes immediately scan the inflamed gut wall, hunting for empty attachment spaces to settle down. Executing a strategy called competitive exclusion, friendly bacteria rapidly claim all available real estate. Harmful pathogens have no room to anchor, bounce off, and flush away. Established probiotics then release targeted natural weapons, bacteriocins, to actively disintegrate any lingering bad germs. The biological perimeter is now fully secured and swept of hostile invaders. The gut is perfectly staged for the heavy construction required to fix the physical barrier cracks. To fuel that heavy construction, the cooked rice component of the meal bypasses the stomach and arrives fully intact in the large intestine. When cooked rice is left to cool in the kitchen, a mechanism called retrogradation occurs. The starches inside the grain, known as amylose and amylopectin, physically crystallize into an incredibly tightly packed structure. This new configuration is known as type 3 resistant starch. Because it is packed so densely, it is virtually invisible to our upper digestive enzymes, completely avoiding rapid blood sugar spikes. A simple temperature change transforms a basic dietary carbohydrate into a targeted, slow-release prebiotic payload designed specifically to feed the lower gut. The newly established security force of friendly microbes eagerly consumes and ferments this resistant starch payload. As a byproduct of this fermentation, the microbes produce healing short-chain fatty acids, specifically one called butyrate. Butyrate acts as high-octane cellular fuel. It provides up to 70% of the massive energy required by the damaged gut cells to start their physical rebuilding process. Powered by this fuel, the gut cells manufacture new tight junction proteins that rapidly zip the broken barrier shut. At the same time, specialized immune responders called regulatory T cells sweep through to pacify any remaining tissue irritation. By cooling thermal stress, securing a microbial perimeter, and delivering precise cellular fuel, this sequence physically rebuilds human defenses from the inside out.